The next step then would be to say, can we do absolute values where they're actually inequalities? Where they're not equal to a distance from 0, but watch this, they're either beyond it. Now if you look at my thumbs, they're going out beyond a distance from 0, or are they within that distance from 0? So you're going to see me do thumbs out or thumbs in based on the inequality symbol. Now this particular problem says I want the distance from 0 to be greater than 3. Right away you have to think of the boundaries. What spots on the number line are 3 away from 0? And I'd hope you'd say, I got one at -3, and I've got one at +3. Those would be where my fifths are. And now I'm saying I want the distance to be where? Greater than that from 0. So am I saying, am I going to be within 3 from 0 or beyond 3 from 0? It's beyond. I'm going to take my thumbs, I'm going to go out. Now if you look at this, what I'm really saying is I want to be less than -3. I want to be further than 3 away from 0 on this side, would be less than -3. I'll put that down. Or I want to be greater than 3. So I have kids in class with their fists showing me where will the answers go. Less than the negative boundary or greater than the positive boundary. So that's what we got to think, is that the answers would not be at the boundaries. I don't want it to equal 3 away from 0. I want it to be beyond that from 0. So that is only going to happen if I go what I call thumbs out, which would mean less than the negative boundary, okay, or greater than the positive boundary. So that's important. Now there's all sorts of ways you can define that and yada yada yada, but the bottom line is you've got to realize where are those solutions going to lie. Beyond 3 from 0. Less than -3, further than 3 away that way, or further than 3 away that way, which would be greater than +3. Okay? Now, if I transfer to the next situation you could have, we've had equality, be a distance from 0. We've had inequality where you're greater than that distance from 0, thumbs out. Or we have this situation where I say, I would like the distance from 0 to be less than 3. So again, you have a boundary where you're 3 units away from 0. But now I want to remain within that. Okay? So the answers are going to sit in here. So if you look at that, you are, now your thumbs are going to go in. So you are greater than the negative boundary, greater than -3, or you're less than +3. Okay? Now again, we can go through all sorts of terminology to explain that, but you simply have to decide with an absolute value, am I at a distance from 0? Am I beyond a distance from 0? Or if I'm within a distance from 0? Those 3 scenarios is all you could possibly have. So here I want the absolute value to be less than 5. Okay? Immediately, you got to be thinking 5 away from 0. Those are your boundaries. So where can that occur? -5 or +5? Now what is this symbol indicating as far as where do I want my distances to be? I want them to be less than 5 from 0. So you simply got to take your thumbs and you got to move them to what that means. Less than 5 from 0 would mean within the boundary from -5 to +5. Now if you look at this, this is greater than -5. I'm to the right of -5, and it's less than +5. So that's the way we want to be able to write that. So I like to split this off. I like to put -5 down here and put down +5, and then you got to say to yourself 2x minus 7, 2x minus 7, and you got to put the truth in between there. Okay? So you have to think. You can never eliminate thinking for math. Less than 5 from 0. Okay, I'm looking for tweeners. So I'm greater than -5, and I'm less than +5. Okay? And then I simply need to solve these inequalities down. So I think the solving part's the easy part. 2x is greater than 2. Looks like x is greater than 1 on this side. And over here, looks like 2x is less than 12. I think x is going to be less than 6. Now again, your job at the end is you can just check an answer. So I'm saying the answers must sit between 1 and 6. So you pick a number like 3 and you see does it work or not. So I put 3 in here. I'd have 2 times 3 is 6. 6 take away 7 is -1. Absolute value of -1 is 1, and that is in fact less than 5. Okay, so it looks like we got it. Now you will see this typically, since there's 2 sides to this thing, a lot of times what they'll do is you'll lump this together and say x kind of sits in the middle. X is bigger than 1, but it's less than 6. Okay? All right, now, let's go to the other side of the ledger over here. And hopefully you can see this and read this. But now I'm saying I want the absolute value of 2x minus 3 to be greater than or equal to 8. All right, so there's my boundary. So that can occur at negative 8, that can occur at positive 8. That would equal 8 away from 0. Now I want to be equal, or I want to be greater than 8 from 0. So thumbs in or thumbs out? Hopefully you're saying thumbs out would be greater than, the fist would be equal to. So if you're looking at this, this would indicate less than or equal to negative 8. This would indicate greater than or equal to positive 8. And that's what you got to be able to do. So again, you're going to write this down. I hope that you have a negative boundary to consider and a positive boundary to continue at negative 8 and positive 8. And I want to be equal or greater than, beyond those boundaries, which is less than that one or greater than that one. And it would look like that. Okay? And then we solve that now. All right? So this is the idea of absolute values. Am I at the boundaries? Is it equal to negative 8? Equal to positive 8? In this case, it was less than or equal to negative 8 or greater than or equal to positive 8. Okay?